Lesson 11.2 is all about arithmetic series. In 11.1 we talked about arithmetic sequences. Now we're going to learn what a series is. So when we add up all the terms from a sequence, it would look like this. It would be our a sub 1 plus a sub 2 plus a sub 3 plus a plus 4 and so on. So whereas before we just said a sub 1, comma, then a sub 2, comma, then a sub 3, and we just got what each of those numbers are. In a series, we're adding all of those up. So the sum of one of these sequences is called a series. When the series that is used is an arithmetic sequence, so our a sub 1, our a sub 1, a sub 2, and a sub 3 all line up exactly with in an arithmetic sequence. So this is a common difference between them each time. When it lines up in an arithmetic sequence, we would call it specifically an arithmetic series. So let's just see what a quick short one would look like. Let's say we have the arithmetic sequence 1, 2, 3, 4, 5. So again, our common difference between them is just 1 each time that it's going up. Whoops, too much. Okay. Now to change it from a sequence to a series, we just add a plus in between each of them. So we're adding all of those together. And when we add all these up, this comes out to 15. Now one neat trick we want to notice here is there's 5 numbers here. And if we take our total that we got, 15, and divide it by 5, it'll be 3. 3 is the middle number here. It is also, if we take our first number and our last number, 1 and 5, and we find the average, 1 plus 5 over 2, that's how you find an average, that would be 6 over 2, which is 3. So it's our middle number, or our average, multiplied by however many numbers there are. So you would find the average of all your numbers times however many numbers there are. That equals the sum, or it equals the what we'd call the sum of this series. So keeping that in mind, that it's always going to be the sum of the averages, if we wanted to find the sum of the first 20 even numbers beginning with 2, well, there's going to be a couple different formulas here we can find out. Whenever we have a sum of a series, we use the S sub n, the arithmetic sequences. We always used a sub n, now we're going to use s sub n. So if we know that we want to find the average, we would say we'd take the first number, a sub 1, or our first term, plus the last one, a sub n, over 2, times however many numbers there are. Now, sometimes you'll see this written another way. Because of the commutative property of multiplication and division, we can put the n out here and put n over 2, and then multiply by the a sub 1 plus a sub n. So you'll probably see it written this way more often than not, but this version here works as well. And it just kind of explains the average sense a little more. Now, this way works if we know what our first term and our last term are, but if we don't, then we would have to say s sub n equals, we know our first term, but if we don't know what that last term is, we would have to replace a sub n with that old formula for a sub n that we know, which remember was a sub 1 plus n minus 1 times d. That's our formula for a sub n. Otherwise, everything else is the exact same. Now, a couple things to notice here. We can essentially get rid of these, whoops, I want that one. We can get rid of these parentheses. We don't necessarily need those. We also can combine these A1s together and just call it 2a sub 1. So now we have 2a sub 1 plus n minus 1 times d all over 2 times n. And again, another way we could write this. A lot of people prefer doing the n over 2 first. Again, commutative property says that's okay. And then just taking this piece. So it would be times the 2a sub 1 plus n minus 1 d. And in fact, these ones on the right, these are the ones that you'll find in your reference packet. But all of these formulas work. Again, this one works, or the top two work when you know the last number. These bottom ones work when you don't necessarily know what the last number is. And in this particular situation, we don't know what the last number is. We just know that we begin with 2, and it's every even number. So again, 2, 4, 6, 8. So we know our common difference is going to be 2, because it changes by 2 each time. And we want n equals 20, because we want the first 20 of them. All right, with this in mind, let's go ahead and plug things into, let's use this version of the formula. So we would say that s sub 20, because we want the first 20 of them, equals, we're looking at this n over 2, so we'd say 20 over 2 times 2a sub 1, well our first number, our first term was 2, plus, and there are 20 numbers, minus 1, and our difference is 2. Okay, so everything's plugged in. Now we just need to start simplifying things. We would say s sub 20 equals 20 over 2 is 10 times the amount. 2 times 2 is 4. 20 minus 1 is 19. 19 times 2 is 38. Okay, things are starting to look a little bit better here. 4 plus 38 is going to be 42. So we would say s sub 20 equals 10 times 42 is 420. So instead of going through and adding up all of those numbers to 4, 6, 8, all the way through 38, 40, that would be the first 20 of them. Instead of adding all these up, we just plugged them into our formula to find out that 420 is the sum of all of them. Oh, those tricksy hobbitses. Here we are figuring out all of our formulas, but in this case, they didn't give us things to plug into this side. They gave us only some of the things, but they also gave us something to plug into our left side. So we essentially need to work backwards to solve for our a sub 1. That's okay though, we know how to do that. We just plug everything in and set it up like we normally would. We know that we have s sub n equals n over 2 times 2a sub 1 plus n minus 1 d. We also know that s sub 31 equals 124,000, excuse me, which if this is s sub 31, that means our n equals 31. That's helpful as well. 31 over 2 times 2 times a sub 1. We still don't know what a sub 1 is yet. Again, we know that our n is 31 minus 1 times d. d was given as 100. So this is everything we know. The only unknown left is a sub 1, which is what we were looking for. So that works out pretty well. So now we just have to start simplifying. I'll scroll this down, give us a little more room. So we'd say 124,000 equals 31 over 2 is 15.5 times 2a sub 1 plus 31 minus 1 becomes 30. 30 times 100 is going to be 3,000. Okay, now we'll just distribute this 15.5. So we get 124,000 equals 31 a sub 1 plus 15.5 times 3,000 is going to come out to 46,500. Okay, now we have to subtract 46,500 from both sides. So we get 77,500 equals 31 a sub 1. All right, and our last step is to divide both sides by 31, which means in the end our a sub 1 equals 2,500. Those tricksy hobbitses thought they had us, but we got them. Oh, they're at it again. This is a much cuter golem, though, but those sneaky hobbits, they think they've got us. Wicked, tricksy, and false. In this case, we need to find the first four terms of the arithmetic series in which a sub 1 equals 14, and a sub n equals 29, and s sub n equals 129. So again, we just plug things back into our formula. So if we know s sub n equals n over 2, a sub 1 plus a sub n, now we just plug everything back in. We know our s sub n is 129. We don't necessarily know how much n we have, so we need to find that first. So there's going to be n over 2. We know that our a sub 1 is 14, and we know that our a sub n is 29. So this is what we have so far, and this is going to help us find n, or how many numbers we actually have. So 14 plus 29 is going to simplify down to 43. And we can do then, we'd have 129 equals n over 2 times 43. So we can divide both sides by 43, in which case then we have, what is that? 3, exactly. 3 equals n over 2. Multiply 2 to both sides, and we're left with 6 equals n. So we know how many numbers we have that we're working with. That's n is 6. Now we need to find our nth term equation. So that goes back to 11.1 stuff, where we had a sub n equals a sub 1 plus n minus 1 d. This will help us find d. Once we know d, we can find the other terms. Again, we just plug in what we knew from before. So we would say 29 is our a sub n equals 14 was our a sub 1 plus n is 6 minus 1, and we don't know d yet. That's what we're trying to find. Well, we can take away the 14 from both sides right away, leaving us with 15 equals, get this down into 5 times d. And now at this point we just need to divide both sides by 5, leaving us with 3 equals d. Now that we know that d equals 3, and we know we started with 14, and we want to know the next four terms, 1, 2, 3, 4. Well, as long as d equals 3, we would just go 3 more to 17, 20, 23, and 26. And that is how we'd find our next four terms. Beat the hobbitses again. For our last piece of information here, we're going to talk about how to find summations using the sigma notation. Sigma is a Greek letter that, or at least the capital version, looks something like this. It's this little guy right here. Or maybe I should say big guy. Anytime you see a sigma, that basically means you're going to sum or add everything up. Now, we're going to be adding things from this equation, but we're going to start from here. So the one on the bottom of the sigma, this is the first one where you start, and this is the last one where you end. So we start with k equaling 3. If k equals 3, we'd have 2 times 3 plus 1. And again, that's our first term is a sub 1. Our last term then, a sub n, is where we had 10. So we'd say 2 times 10 plus 1. Now all we have to do is just solve those out. 2 times 3 is 6, plus 1 is 7. 2 times 10 is 20, plus 1 is 21. So a sub 1 equals 7, a sub n equals 21. We still need to find our summation though. So we still need that s sub n equals n over 2 a sub 1 plus a sub n. Now we don't necessarily know yet how many numbers we have. We need that n, but we know that we start with 3 and we go all the way until 10. Well, how many numbers are there? That's 3, 4, 5, 6, 7, 8, 9, 10, in which case 3 is our first number, 2, 3, 4, 5, 6, 7, 8. There are 8 numbers that we're looking for. Now a quick way to do that is take your top number, in this case 10, minus your bottom number, in this case 3, and add 1. In which case 10 minus 3 is 7, plus 1 is 8, which is the same as what we had there. So now we know that our n equals 8. So we can plug everything into this formula. Give us a little more room down here to do so. S sub n equals 8 over 2 times our a sub 1 was 7, that was from up here, plus 21 was our a sub n. Now we have a little bit of simplifying to do. 8 over 2 is 4, times 7 plus 21 is 28. So now we just need to know 4 times 28, which is going to be 112. So technically we know our n value too, so we wouldn't say that it's s sub n, it's actually s sub 8. So we'd say our sum, s sub 8, is 112. Well, that's all I got for you. Make sure you're asking any questions on arithmetic sums and series or sequences. Otherwise, stay golden.